Hello everybody, getting ready to do lesson 6.6, lecture version of 6.6, which is the unit circle for SAT Math Level 1. This course includes at least 70 lessons. If you need quizzes or tests, worksheets, or backup lessons, if you're weak on trigonometry, for example, or geometry, I can provide those to you. Just email me here and I'll get those out to you. Today, we're going to do lesson 6.6, a unit circle, 58 points here on your tune-up, and then 38 points in this lesson here for note-taking on your lecture. Hello everybody, back to slide 1 here, overview of 6.6. A unit circle is a circle with a radius of 1. This is important. The coordinates of a point on the unit circle centered at the origin in the xy plane can be expressed in terms of cosine and sine. So that's nice to know. Here's a unit circle here. Here is your unit of 1 here on your what's called the terminal side of angle theta. This is a right angle here from the x-axis up to this point here on your hypotenuse, and your r equals 1 here. This is 1 unit here. The terminal side of angle theta intersects the unit circle in xy plane at point xy. So point xy here, point xy equals the point where cosine theta and sine theta, since cosine theta equals x over 1 equals x, and sine theta equals y over 1, which equals y. So this is your trigonometry functions here as it concerns a unit circle. Sine squared theta plus cosine squared theta equals 1 because x squared plus y squared equals 1. This is your Pythagorean equation here for this here to find your length of your hypotenuse on your right triangle here. X1 plus y1 equals 1. Equals 1 squared. So x squared plus y squared would equal 1 in this situation here. 1 zeroes out here, so for your Pythagorean theorem to work, this has to be x squared plus y squared would equal 1 squared. Range of values of sine and cosine. So in this case here, since the y values of sine and cosine functions are coordinates of points on the unit circle, -1 is less than or equal to sine theta, which is less than or equal to 1. So that would be another way of looking at your values here on your unit circle. And sine 3 pi over 2 would equal -1. So the sine of 3 pi over 2 would be down here, would equal -1. That'd be your y value. This would be your pi over 2. This is pi, then this is 3 pi over 2, and then this would be pi over here. So on the unit circle, -1 is less than or equal to sine theta, and in this case here, and then sine theta would be less than or equal to 1, which would be over here. So cosine 0 equals cosine 2 pi, which equals 1. So cosine 0 here, which would be 1, 0, would be cosine 2 pi, which is 1 complete revolution here of your unit circle, would equal 1 here. And cosine pi would equal -1. That's over here. This is pi over 2. This is pi here. So cosine pi would equal -1 here. This would be your y value over here. Okay, let's go into an example. In a figure, if cosine theta equals -0.36, what is the value of sine theta to the nearest hundredth? So, and these are our possibilities here, to the nearest 100. Use this relationship here, sine squared theta plus cosine squared theta equals 1, to solve for sine theta. And this is our Pythagorean setup here. So sine squared theta plus 0.36, we're going to plug this into here. Negative 0.36 should be negative 0.36 squared equals 1. Okay, continuing to solve this trig equation. So for cosine squared of negative 0.36, we get 1 minus 0.1296. We're solving for sine squared theta now. And so when we take the square root of this, 1 minus this amount, we get plus or minus square root of 0.8704, which is 0.93. So there is your solution there. Since sine is positive in quadrant 2, which should be over here, sine would be positive because your y values here are positive. It would be 0.93 would be the solution for that trig equation. If sine w equals a and pi over 2 is less than w and w is less than pi, what is the tan w in terms of a? And then here are our possible solutions for that. So we know if it's less than, if it's between pi over 2, which is here, and pi, it would be in quadrant 2, would be our solution. The terminal side of angle W in standard position intersects the unit circle in quadrant 2 at a point P over here, whose x-coordinate is cosine W and y-coordinate is sine W. So we have cosine W and sine W be somewhat over here. Then here is our W, our angle W. Form a right triangle by dropping a perpendicular to the x-axis. So we saw this in the last slide. To the x-axis is shown in the accompanying figure. This is kind of a diagram of the problem. The lengths of the legs of the right triangle correspond to the coordinates of point P, which is here, which is cosine W, sine W. So again, using that diagram, use the Pythagorean theorem to express x equals cosine W in terms of a. So we're going to stick an a in here. X squared plus a squared equal 1. And then we solve for a now in terms of x, or rather x here in terms of a. So x equals negative, the negative of the radical 1 minus a squared, which equals cosine W. X is negative in quadrant 2. So that would figure. So find tan W. So tan is sine over cosine W. So we have a over the negative of 1 minus a squared radical, the negative radical of 1 minus a squared, which equals this symbol here, which is b for that one. Okay, we go into another problem here. Point P is on a unit circle with center at 0, and point A is the point at which the unit circle intersects the positive axes. If angle AOP, so wait a minute, where are we at here? And point A, where's point A at? Well, it's over here. So, and point A is the point at which the unit circle intersects the positive x-axis of angle AOP, which is this angle here, AOP, is 7 pi over 6 radians, which is here. What are the coordinates of point P? So we have this factoid here, and we have a unit circle, which we know is 1. So theta is 7 pi over 6. Then theta is in quadrant 3, which is down here. And the reference angle is pi over 6, which is 30 degrees. So it's pi over 6 from this 180 here. The right triangle that contains the reference angle, which is this right triangle here, is a 30, 60, 90 right triangle with a hypotenuse of 1. We know that much. Since x and y are both negative, we're down here, x and y both negative here. In quadrant 3, x equals negative square root of 3 over 2. X is negative square root of 3 over 2. And y is negative 1/2, which is this coordinate here. So this is negative 1/2. This is the negative square root of 3 over 2. So here are our coordinates of P here. Simple, actually. Math reference. Fact, when finding the coordinates of points on rays whose angles of rotation within the unit circle are multiples of pi over 6 and pi over 4, use these special right triangle relationships. So we have 30, 60, 90 here. And then this is a 45, 45, 90 here. And this is a pi over 4 triangle. And then this here is a pi over 6 triangle. If cosine x equals a, cosine w equals negative a, and then negative pi over 2 is less than x, and x is less than 0, which of the following is a possible value of w? So cosine x is a, cosine w equals negative a, and we have this situation here for x. So we're trying to find the value of w. Since negative pi over 2 is less than x, and x is less than 0, cosine x equals a. Locate the point AY in quadrant 4. I mean, we know it's going to be a quadrant 4 because the negative pi over 2 will be going in this direction here. With reference angle x, we need to find the angle W. So this is our point here. A and Y is here. That the ray through point negative AY. So negative AY is here. So go through here and it goes like this. Makes a positive x-axis. So locate point negative AY. Negative AY is over here. Since the reference angle is also x, this is the x here, over here, and then this is the reference x over here as well. The angle of rotation W is pi minus x is shown. So here's our reference angle here, pi minus x in this case here. Periodic functions. The sine and cosine functions are periodic. A function is periodic if its values repeat at regular intervals. The sine and cosine functions each have a period of 2 pi radians, since each time 2 pi is added to an angle or subtracted from an angle, we go around a unit circle. And okay, returning to the same point. So when you add 2 pi to x, you go back to sine x here for sine 2 pi plus x. And for cosine x minus 2 pi, you'll go back to cosine x as well, because you're going back one complete turn for cosine, and then with sine, you're going one complete turn. You just go back to the same point you started with. This here is assuming that you've had some background trigonometry. If you have not, then you need to get a hold of me to get some trigonometry lessons, which I can assign you. Okay, symmetry in a unit circle. P prime is a reflection of P in the x-axis. The angle OP prime makes with the terminal side is equal in measure but clockwise in rotation compared to the angle OP makes with the terminal side. Thus, the coordinates of P prime are cosine negative theta and sine negative theta. And then this is your example here of uh, cosine and negative theta and sine negative theta would be down here. And then cosine theta and sine theta would be up here. This is your theta here. Because P prime is a reflection of P in the x-axis, it has the same x-coordinate as point P, but the opposite y-coordinate. So cosine negative theta equals cosine theta, and sine theta equals the negative of sine theta. So again, we go back to this here. You have different y-coordinates here. For this one here is positive. For down here, it's negative. You have a negative y-coordinate down here. And then that reflects in your trig functions here for that. Since tan theta is a quotient of sine theta divided by cosine theta, tan negative theta equals the negative of tan theta. General reduction, again, that requires some background. If you need trig background, email me. General reduction relationships for the SAT test purposes to determine whether a general relationship such as sine x plus pi equals the negative sine x is true or false, use a convenient test value for x. So if x equals 30 or pi over 6, then x plus pi is in quadrant 3. And the angle and the reference angle will be 30 degrees. So this is pi over 6 here. Here's your reference angle here for 210 degrees. Again, if you're not getting this, you need background trig. So get a hold of me for trig lessons. Sine is negative in quadrant 3. So sine 30 plus 180 equals sine 210, which is the same thing as negative sine 30. You can then make the generalization that sine x plus pi equals negative sine x. Similarly, sine x minus pi equals negative sine x. Again, this is this here. So it'll be sine minus 30. So this would be sine minus 30 here. Illustrating that sine 210 equals a negative sine 30, which would be this angle right here. And that is your lecture for 6.6. If you need trig background, if you need to brush up on your trig, get a hold of me here at this email, and I can get some trig lessons out to you. Thank you very much.